Very happy to be here. Thank you for inviting me, and excited to talk about Mars Heli and the future generations coming. We good to start?
Yeah, please. The floor is yours.
Okay. All right. So yeah, good morning, good afternoon. I've lost track of the time zones now. I think it's still morning there in Italy. I apologize I couldn't make it in person. And let's kick things off. So my name is Tzanetos. I'm going to be talking to you, like Jean-Pierre said, about our current generation of Mars rotorcraft and the two generations we'd love to be developing here for the future. One for Mars sample return, and one more future looking as a concept for larger, more capable rotorcraft. Much more akin to the next presentation that you're going to be hearing from Ralph on Dragonfly. So get excited for the next talk as well. All right. So first off, we wouldn't be anywhere without our fantastic team. We've been flying our baby Ingenuity, 1.2 meter rotorcraft on Mars for 2 years now on the Red Planet. And that's taking a lot of people from our original tech demo team on the bottom right-hand corner of the screen. And now the extended ops demo team on the upper left, several generations now of team members in terms of the original designers, first round of operators, second round of operators, third round of operators, and just want to say thank you to the team. Here is our baby. So Ingenuity is a 1.2 meter from tip to tip coaxial rotorcraft system, right? It's the most efficient volume-wise aircraft design that we could have thought of for the Mars 2020 mission. 1.8 kilos, and the rotor blades, because Mars's atmosphere is so thin, spins at around 2,500 revolutions per minute. Here's where Ingenuity stowed aboard Perseverance for the mission to the Red Planet, right under the belly of Perseverance. You can see it here in the red circle. And once we were finally deployed, here's a selfie that the Perseverance rover took once we deployed Ingenuity onto the surface. Sorry about the slide advancing, having some difficulties here. Want to first just state, we succeeded in our mission goals back in 2021, right? April 19th, when we had flight number 1, that was really the main goal of Ingenuity. Prove that flight was possible, have our Wright brothers flight on another planet, and check that box, right? Every flight after that is gravy, in the sense that it's additional benefit to humanity, it's additional benefit to our engineers, and it's providing a treasure trove, we hope, for the generations to come. This is just a small animation of, quick little animation of what that first flight looked like. Hopefully this is coming across well over the Zoom here. But it was a simple, modest flight, 3 meters up vertical, hover for 39 seconds. We did a yaw rotation, hold, record a couple of images, and come down. This is from the perspective of the mast cam Z payload aboard the 2020 Perseverance rover. And since then, we've really expanded what our mission has been about, right? So this is an orbital image of the Jezero crater region on Mars. We started off in these blue boxes. You can see flights 1 through 3, and then flights 4 through 5 after that. Thankfully, our original tech demo mission, it was just 30 sols, 5 flights. That is what we designed for, so we were budgeted for. Afterwards, we still had a healthy aircraft on our hands, right? And we wanted to keep expanding the flight envelope, scouting for the rover planners, scouting for the scientists, and thankfully NASA headquarters agreed, and we extended our mission beyond that. And the animation you see here shows each single flight after that tech demo, along the green lines. Each one of those green line segments is a single individual flight in between the yellow dots. So our first campaign after that was our South Sita campaign, where we scattered around. If you can imagine, this forms a glove. There's the thumb of South Sita. So the helicopter took a shortcut, flew to the south, came back to the north. After that, we flew across the Sita area, had our longest flight of 704 meters, and we're currently in the process of climbing up the Jezero River Delta. We're right now just ahead of the rover. We have up to flight 51 on this map. We believe we've executed flight 52. Still waiting on downlink and confirmation of safe landing. But it's been a wonderful success in terms of proving out the longevity and the robustness of the Ingenuity design. Also want to call out in the red circle here, we'll come back to this in a couple of minutes. This circle is where the Mars Sample Return cache depot site is located currently. So right now, there are 10 sample tubes on the surface of Mars, right around where that red circle is. So here's just a couple of bullet points summarizing the mission to date. Right, so we've completed our original tech demo. The original goal of prove that flight was possible at Mars. We explored South Sita. We're in the river delta now. Hundreds and hundreds of images, thousands and thousands of data points from our GNC sensors, all that we're gonna, make available to researchers around the world. More than 11 kilometers of total distance flown, about an hour and a half in the air, in the skies of Mars, right? So it's been a wonderful success. Ingenuity continues to be. We hope to keep flying for Ingenuity for as long as we can, to also understand the aging mechanics, right? We're using a cell phone processor. We're using cell phone cameras, cell phone MEMS, IMU, accelerometers, and gyroscopes in the cold, bitter nights on Mars that Mars has for us, right? So even just the act of surviving another night helps us understand and buy down risk for future missions that rely on these off-the-shelf technologies. Here are some highlights from the mission. In Flight 13, we developed a three-dimensional map. We stitched together our color, high-resolution photos. And these sorts of maps are a new tool that rover planners from an aerial perspective, right, haven't had the advantage to, or the ability to benefit from. Yes, the rovers can take much higher resolution images, but from a fixed rover altitude, right? We can now send aircraft ahead and go where the rovers can't to go get these sorts of scouting images. This animation here shows you what the difference is compared to orbital, right? So the original image is an orbital shot of the Faifu outcrop, and you can see once we project the Ingenuity images on top, the step up in resolution that we can provide mission planners. And of course, we've had a lot of fun flying around the surface of Mars and capturing images of other aspects that we've left on the surface, not just images of the rover itself, but of the EDL debris, in which we were trying to learn some lessons for the next mission, Mars Sample Return. So in summary, Ingenuity has been a wonderful success. We know that the design's robust. We know that we can fly up to 700 meters in a single sortie. We've demonstrated we can turn around a flight on the order of 3 sols, right? So we can get our decisional data down on the ground here at NASA JPL, plan a flight, simulate it, and send it back up in quick succession. And then, of course, I already mentioned our commercial off-the-shelf parts are still working after 2 years on the surface. So it's a very good foundation on which to build the next aircraft mission to Mars, which is for Mars Sample Return. So for those of you not familiar, I'll just summarize briefly using this, we call it an elephant chart. Mars Sample Return is the combination of a handful of segments which started with Mars 2020, right? So Mars 2020 has Perseverance, whose objective is to collect these precious sample tubes. We hope to launch in 2027 and 2028. The plan is an orbiter, which we're calling ERO. This will be our return trip home and our telecom link for the mission. And then in 2028, we're going to be launching the Sample Return lander, right? On board that lander will be the Mars launch system. So there'll be a rocket built into the lander. And that's what's going to help us bring the sample tubes. This is a sample tube here. It's about 6 inches in length or so, inside of which is roughly 50 grams of sample of regolith from the Martian surface. And the plan is by 2033 our samples will return to Earth, and we'll have our sample receiving project where we're going to build around the landing site one of the most advanced facilities ever, so that we can try and study these sample tubes and understand, was there ever signs of life at some time on Mars. Where the helicopters come in is the backup plan, right? So the scenario one is that the Perseverance rover will drive directly up to the lander, transfer the tubes over, and then the MAV launches the Mars Ascent Vehicle, the rocket inside the lander returns the samples back home. Scenario number two is that if in the next decade there's an issue with Perseverance, we have a backup plan, right? And it's directly as a result of the success of Ingenuity that NASA was willing to consider such a concept. And they came to us and asked, hey, would it be possible to take Ingenuity's design, tweak it so that you could pick up a sample tube? And that's what our team here at JPL is, and AeroVironment have been busy doing now for the last year. So how do you take Ingenuity and make it into an aircraft that can pick up tubes? First, we want to make sure, do no harm, right? So make it as reliable and safe as possible, just like Ingenuity was. You need to add an arm, add a mobility system. The concept of operations requires that we can retrieve a tube, fly out to the sample depot, and bring a tube back every 4 sols to fit within the timeline. Of course, we want to maximize heritage, all the lessons learned from Ingenuity, both design-wise and the doing-wise. And of course, stay within budget and schedule, right? And here's an animation that, similar cartoon that just shows you all what we're thinking when we say take Ingenuity's design and upscale it really in terms of capability. You start with Ingenuity, you add 4 wheels, 1 for each foot to allow us to do tank-style driving. Some form of a manipulator and a docking system so that you could reach down to the surface, pick up a tube, and bring it back to the body of the aircraft. And on the lander side, this is an image of Perseverance, actually. Inside the blue box here is our helicopter base station, right? So it is our man-in-the-middle communication relay system between the Perseverance rover and the helicopter. We will be doing something similar here, where we'll have an internally redundant base station on the lander, right? So very similar functions as what we did on 2020. And here is an example of our antenna on Mars 2020, right? So the reason, the takeaway here is we need to be more reliable, right? So we're going to send 2 helicopters for reliability, eliminate single point failures. Our base station will be internally redundant, and we'll have 2 telecom antennas as well. Here's a comparison table if you wanted to just understand the quick similarities and differences between Ingenuity and SRH. The rotor diameter, actually this table's this chart's out of date. The rotor diameter we actually expect to grow slightly, right? So we're going to be pushing from 1.2 meters up to closer to 1.4 meters in radius. The mass will be growing, right? And that's a big challenge for us on the surface of Mars with such a thin atmosphere, to go from a 1.8 kilo vehicle up to around 2.3, 2.35. Ingenuity did not have a payload. We will have around 150 gram sample tube to carry, right? So a comparable mission, right? But some serious engineering challenges to go from a tech demo to now a Class B reliable version of that aircraft. Here's a simple diagram showing our concepts of operations, 4-sol cadence. I won't spend too much time on this because I want to make sure stay within the budget here for time, and also in case there's any questions. But the quick ConOps is, first sol, we fly out to the cache depot, 700 meters to 400 meters. Second sol, we drive up, pick up a tube. Third sol, we fly back to the lander. And the fourth sol, we drop off the tube. And then rinse, repeat. Do that as quickly as we can to pick up those 10 tubes in the Three Forks area in Jezero Crater. And here's just a high resolution shot of our current most up-to-date design for the sample recovery helicopters. And very briefly, what might come after that, right? The dreaming people at JPL are dreaming up the next version of aircraft. And this is to answer the question, if scientists could have a bus in the sky on Mars, it's how I like to describe it, If all the engineering challenges are taken care of and we can now carry meaningful science payloads around the skies on Mars, what would the scientists want to do with it, right? So we're designing Mars Science Hexacopter, which is the size of a large SUV, or really the rover itself, so that we can carry payloads in the 2 to 5 kilogram regime. I'll skip some of these detailed bullet points here and get to an exciting video, which really, I believe, gets to the heart of what Mars Science Helicopter is all about, right? Unlocking that aerial aspect, not just, Ingenuity has unlocked that aerial aspect for scouting, right? We know we can get wonderful images. Now, in terms of exploration, right? Unleashing ourselves from the telecom constraints of a rover and being able to fly arbitrarily on the surface of Mars wherever the scientists wanted, right? Go up a cliff wall, bring these science payloads, as I said, in the 2 to 5 kilogram range, anywhere you want on the surface of Mars. Go to biologically sensitive areas, be able to hover over those sites and deploy a payload, perhaps pick up a piece of regolith for examination at a different location. Here's just a artist's rendition again of being able to dive down into a lava tube, explore areas that we know rovers can't get to, other sorts of landed assets wouldn't be able to go explore. And that's really the whole purpose of Mars Science Hexacopter. There's some papers out there, IEEE Aerospace, for those who are interested, that delve further into this idea. Also, some of the GNC and rotorcraft design challenges that would be involved. So I encourage you all to go check it out. And thank you all very much for your time. Really appreciate it.